Hi dear students, so today we have come to discuss about some numericals on gravitation of class 9. In the previous class we have discussed about gravitation, though I know the length of the video is little longer because I just want to include everything what you want, it is what is important for you, but maybe it is little longer video. My suggestion is if you are feeling bored, then see it step by step, then it will be better for you. Today we'll do some numerical from gravitation. So before starting numerical, what equations we have to remember that we have to see here. So our targets is to do the numericals on gravitation. Okay. So whenever we are talking about the equations, the important equations, the first equation that comes, that is the Newton's law of gravitation, that is force equals to G m1 m2 by r square. Okay. Number two, second equation, that is the equation of gravitational acceleration, that is G capital M by r square, where G is the universal gravitational constant, M is the mass of earth, r is the radius. And number three, the equation of falling body, and there we have learned there is a three set of equation is there. Number one, V equals to U plus GT, H equals to ut plus half gt square, and v square equals to u square plus 2gh. This equation should be used when the body falls downward, because if a body come downward, then it is a motion along the direction of the gravitational acceleration, and if it moves upward, then for that another set of equation, that is v equals to u minus gt, h is equals to ut minus half gt square, and v square equals to u square minus 2gh, and that is for upward motion. So this equations we have to use in case of numericals. Okay, so that is our target. But here, if I'm talking about that, whenever we are going to discuss about the Newton's law of motion, for that case, what type of numericals can come from this equation that we have done by taking the mass of earth, mass of moon, what should be the attraction force, etc., we have done. From gravitational acceleration, if we do, okay, we know the value will come for earth, it is 9.8 meter per second square. If I put the value g, that is 6.67 into 10 to the power minus 11, the mass of earth, that is 6 into 10 to the power 24, and here r, that is 6 into 10 to the power 6 whole square. So it will come 9.8 meter per second square, that we know. So from here also the part of numericals already we have done, but which one is very much important for you, that is for falling body. These equations, from these equations the numericals we have to practice, and these are very much important for us. Okay, part 3, so that is our target. So here we will do some numericals from your book only. Okay, that is concise physics. Whatever the numericals I have done, apart from that also many numericals should be left, so that you have to do it by your own, and if any doubt then ask me. Okay, so we'll go from numerical. So I'm trying to do that type of numerical which seems to be a little harder, although the numericals are very easy. I'm coming with numerical number 11. Okay, that is in exercise 3E. Exercise 3E, numerical number 11. See every part what I have done. Okay, otherwise sometime I have seen the numericals I have done in video, then also you are having some doubt. So please see it properly, try to understand and do with me along with your copy, then only you can able to understand. Question is given, a ball is thrown vertically upwards. It goes to a height of 20 meter. So here I have got the first information that is given to me, that is height equals to 20 meter. Okay, then what is told? And then it returns to the ground. Means simple thing. Here it's the ground. You have thrown a body vertically upward and it comes downward like that. So this height, that is 20 meter, it is given to you. And now think, whenever the ball is thrown in an upward direction from the point A, it reaches to the point B and come to the point C. So B is the maximum height, B point, it is the maximum point. So at maximum point, what will be the velocity? So we know that at maximum height, v equals to 0. We all know that at maximum height, whenever it will reach, so here the velocity is 0 and then it comes downward at a maximum height. Now the question has come, the gravity acceleration due to gravity, that is given 10 meter per second square. Now coming to the first question, the initial velocity of the ball. That means you have to find out u. The u is not given, by which velocity you have thrown it upward. Okay, so how you have to do it? See, you are having g, you are having v, you are having h. You have to find u. Which equation you have to use? That is a very important thing. So for first question, I'll go for the equation, that is v square is equals to u square minus 2gh. Now you might be asking, sir, why we are taking minus? Because simple thing, A to B, in this case, it is an upward motion. So for the case of upward motion, we know that we are moving against the gravitational force. The acceleration due to gravity, it is acting downward, but we are moving upward. So the direction is opposite to each other, and that means we have to take minus. Simple thing. So if I put the value, v square means 0, u square I don't know, minus 2 into g means 10 and h means 20. So if I've taken this side, so u square equals to, it is coming 400 and u equals to root over of 400, that is 20 meter per second. 20 meter per second. That is our initial velocity by which it is thrown. Next question, the final velocity of the ball on returning the ground. That means you have to find the velocity, the next target, that you have thrown the body here with a velocity u equals to 20 meter per second. What will be the velocity when it reaches to the point C? When it reaches to ground, what will be the velocity? So next target is velocity at point C, that is equals to Vc. Let we are assuming that velocity should be Vc. Now assume whenever a body is thrown and it is coming downward, what will be the net displacement? Net displacement from A and C. So you have thrown from ground and it will reaching to the point again to the ground. So net displacement A to C, that is in a same height, that is equals to 0. Because you see, displacement means displacement above the ground. Not you are thinking about the displacement between these 2 points. No, you have thrown upward and when it will come, again it will reach to the ground. So net displacement H should be 0 here. Okay, and then we will again use the same equation. Okay, what should be the equation? That is V square equals to U square minus 2GH. So initially we have taken our final velocity is 0. But here when it will reach to point C, then definitely it should have a velocity, and that should be Vc square is equals to U square minus 2 into 10 into what is the value of H here? In this case, whenever it will reach A to B, the displacement is 20 meter from the ground. But when it again reaches to C, so displacement is 0. So here we can say that Vc square equals to U square. So Vc equals to U, that is 20 meter per second. So when the ball reach to the ground, that time also the velocity should be 20 meter per second. Okay, I think it is clear. Now we're coming to the next part, that is point C. The total time of journey of the ball. Total time means you have reaches to the point A to B and then you will reach B to C. Total time. Now you can do it in two different methods. One, you can directly find the time period. Otherwise, first you find the time A to B, assume that time is T1, and then B to C, the time is T2, then add it. But I will prefer that if you find it directly, because otherwise you have to calculate two times. It is difficult. Okay, so I prefer whenever you have to do it directly. So let the total time is equals to T. Okay, so here which equation we have to use? What we have to find out? We have to find out the time period. What we are having? We are having V, G, H, everything is there. But better we will use that equation which is comparatively easier for us. Okay, so let's see which equation is comparatively easier for us. So better we have to use the easiest one, H equals to ut minus half g t square. H equals to ut minus half g t square. So here you see we have to find out the total time, right? So total time means from A, B, then C. So here what is the total displacement H? So total displacement we have already seen that H equals to 0. Net displacement it is 0 because you have started from ground and it will just reach to the point here to the ground again. So total displacement H equals to 0. You have find out it is 20 meter per second. T you have to find it out, and the value of G, that is 10 meter per second square. So let's put the value 0, 20 into T minus half into 10 into T square. So if you have taken this side, so 2 5s are 5 T square is equals to 20 into T. So T will be cancelled out. T will be 20 by 5. 4 seconds. So it will take 4 seconds to reach to the ground after throwing. Or I have already told you can do by another way also. You can able to find the time period from A to B, and then you can find the time period from B to C, and you can add. But I think that procedure is little much hectic. Okay, and here it is very much easier for us. Okay, understand the steps. I think everything is very easier for you. Now we'll go for the next. For the next question, we'll go question number 17. I think it is a little more complicated. Not too much, little. Question number 17. Question number 17, what things are given here? First we have to see. So it is given a ball is thrown vertically upwards with the initial velocity 49 meter per second. So u, that is the initial velocity, that is 49 meter per second. It is given to you. Next, calculate the maximum height attained. Okay, the time taken by it before reaches the ground. Okay, and the value of g it is given, it is 9.8 meter per second square. Now first target is to find the maximum height. So here one information is given but in disguise, so that information we have to find out. What is that? That information is at maximum height, final velocity, that we have seen in the previous numerical also, v equals to 0. At maximum height, final velocity v equals to 0. So you have to find what? The height. So let the height is equals to h. And now the question is that which equation we have to use. So clear here, no time period is given, so we will go for v square equals to u square minus 2gh. Here also we have to take minus because it is told again that it is an upward motion. It is starting from here and reaching to the ground again. Okay, so here height is h. Height means we are talking about maximum height. Up to how much height it will reach. Okay, from A to B. So let's put the value first. So v square, that is 0, u square means 49 square minus 2 into 9.8 into h, or h equals to 49 into 49 by 2 into 9.8. So let's calculate it. 98 5s are 49, and here if you see 2, it is 2.5, and if you calculate it is 122.5. let's see the question. Yes, it's right, 122.5 if you multiply this much of meter. So that is the first answer you have already got, that up to how much height it will reach. Next question is the time period. Time period means same thing, time to reach from A to C is equals to t. Let we are assuming the total time it is taken, that is t. Okay, now the question has come that here if I am talking about from A to C, then what will be the net displacement? You are starting from A and reaching to the point C, so net displacement will be 0, h equals to. You might be confusing, sir, here we have taken h, it is 122.5, why we are taking h here, it is 0. Here h means the height A to B, but when we are talking from A to B and then C, net displacement is 0, again it reaches to the ground. So which equation we have to use here to finding out the time? So my suggestion, better you have to use h equals to ut minus half g t square. Okay, that is the equation. Better we have to use. Now the question has come, so why we have to use this equation? Because as we have to utilize the height h equals to 0, so apart from any other equation, this equation is there where h and t both is there. In rest of the equation you see h and t together, it is not here. So if I want to utilize this h, we have to use this equation. Put the value 0 into 49 into t minus half into 9.8 into t square. So let's take t square here. So half into 9.8, 9.8 means it is 4.9. 4.9 t square is equals to 49t, and 4.9 t cancel out, it is 49, so t equals to 49 by 4.9, 10. 10 seconds. So from A to C, we have to take 10 seconds to reach to the ground. Okay, I think it is clear. If you are not able to understand, pause the video here and see how it has done. We'll go for the next equation. I'm sorry, next numerical. So we'll go for numerical number, I think it is 19. Yes, we'll go for 19. So question number 19, according to me, it is the best numerical in your book. Okay, and very interesting also. Let's see what it is told. A pebble is dropped freely in a well from its top. A well you all know. Here it is used in many areas to take water from it. So assume it is a well. This is the level of water. A stone is just left from top. So it is coming downward. Okay. So what it is told? So it tells that it take 20 seconds to reach to the level of the water. Okay, so whenever it reaches to the level of the water, it will take 20 seconds. Okay, whenever it is thrown, you see, it is not thrown just like this way. It is told that a pebble is dropped freely. Freely means just it is taken and leave it. Okay, no extra velocity is given. So from freely we can say that u equals to 0. Initial velocity, it should be 0 because it is thrown freely. No extra velocity is given to it. So u and t is given to us. Next, g equals to, the value of g equals to given, it is 10 meter per second square. Okay, and the speed of sound, so here we have to mention Vs, that is speed of sound, it is 330 meter per second. What is the utility of it? We will learn later. Find the depth of the water. Okay, so depth of the water means you have to find this. Okay, let this is h. So let the depth of water is equals to h. So you have to find the value of h. What things are given to you? Tug, it is given to you, and it is coming downward. So it is a downward motion. Which equation we have to use? Simple thing. H equals to ut plus half gt square. Why plus? Because it is a downward motion. Downward motion means in which direction the stone has come, the direction of gravitational acceleration is also in same direction. That's why we have taken it is positive. So let's put the value of u 0 into time t 20 plus half of 10 into 20 square means 20 into 20. So it will goes to 0. Let's see, 10, okay, 100, 20 into 100, and that means 2000. Okay, so h equals to 2000 meter, that much length. So this is the depth. Now the question has come, the next question, the time when the echo is heard after the pebble is dropped. See, whenever it will reaches or it will touch the water, we will get a sound of splashing. Okay, whenever we have thrown a stone on the water, on the surface of the water, we have seen the splashes here. So the pulses, whenever the sound will form due to the pulses, it will reach to our ear. Okay, so now see how much distance the sound should cover. Now the sound should cover a distance of 2000 meter, right? So how much time it will take to reach our ear after splashing? So we can mention here that after splashing, it will take t dash second to reach our ear. Okay. Now let's find the time period. We know the speed of sound is given and the distance is also given. So time t dash is equals to distance by speed of sound. Okay, and if you calculate here 2000 by 330, and it will come 6.066, so it will continue. So we can take on an average it is 6.1 second. So it will take 6.1 second to reach to our ear. Now the question has come, the total time after throwing, means whenever you have leave the stone and then you have listened the sound, how much time it will take, the total time. So total time means the time to reach to the surface of the water, that is t, plus when the sound is created here, it will take a time t dash to reach to your ear, so t dash. So total time should be t plus t dash, so that is 20 plus 6.1, so it is 26.1 second after throwing, and then it will reach to your ear. Total it will take 26.1 second. Okay, instead of 26.1, if you write 26.066 second, then also it is a correct answer. So to just compare with your book, I have taken an average. Simple thing. Okay, so that is the numerical number 19. Okay, if you not understand, then again rewind the video and see it. I think you can get it. So it is a very easy numerical. And then we are going for the last one, and it is the bombastic one. Why I am telling you the bombastic one? Is it too hard? No, but it is too lengthy. That's why sometimes students are frightened with it. So before doing the numerical, I am telling everyone, see the steps I have followed. Otherwise, you cannot able to do this numerical. Okay, again you will forget, and you will forget how it is done. So that's why I have told that see the steps what I have followed. Okay, now let's see. A ball is thrown vertically upwards from the top of a tower. So let's see a diagram. So assume it is a tower. The ball is thrown from the top of a tower. So the ball will follow this path. Okay. Whenever you have thrown the ball, it will just reach to a height and then it will come to the ground here. It is the simple process. The initial velocity of the ball is given. So what is given? U is equals to 19.6 meter per second. And next thing, the total time to reach the ground means from here to here. So first we have to mention the points. Let this point is A, this point is B, and this point is C. So we can write from A to C, it will take t equals to 5 seconds. Okay, from A point to C point, it will take 5 seconds. Now it is told calculate the height of tower. Okay, so before starting anything, we have to first assume the height of the tower. So let the height of the tower is h. Okay, this is the height of the tower. And now whenever I have thrown from A point, it will reach to a height B. So from A to B, it is h1. We are assuming. Okay. And from B to C, it is h2. It's a very simple thing. And to find the h, we know that h should be equals to h2 minus h1. So if I find h1 and if I find then h2, if I minus it, then I can easily find out the length of the tower, the height of the tower, and that should be very much easier for us. So what is my position? My position is at point A. So at point A, your initial velocity is 19.6 meter per second. Okay. So let's see how much time it will, how much height it will reach whenever it comes to point B. So we can say at point B, V equals to 0. That is the final velocity. Okay, so my target is clear. First I have to find h1, then I have to find h2, then h2 minus h1, I will get h. That is my target, simple target. So first I am going to find h1. So at point B, my velocity should be 0. That is the final velocity. Initial velocity is already given, it is 19.6. Now, what is the value of g? If you see the book, the value of g, it is 9.8 meter per second square. Now, as it is an upward motion from A to B, it is an upward motion. So which equation we have to use? V square is equals to u square minus 2gh. This minus sign we have to use. Now at B, we have already taken the V is 0, 0. U square equals to 19.6 whole square minus of 2 into 9.8 into h means what is the height here from A to B? h1. Let's take it this side. h1 equals to 19.6 into 19.6 by 2 into 9.8. 2 into 9.8 means 19.6. So it is 19.6 meter. So it is our first answer, that is h1. h1 equals to 19.6 meter. Next we have to find h2. Now the question has come, how we can able to find h2? Because you see, to find h2 we need to take the help of this time, but here the time is given 5 seconds. 5 seconds means the total time from A to B then C. Okay, so total time is given. If I find the time from A to B, then I can minus it from 5 seconds and then we can able to find from B to C how much time it is taken. Then it is easier for us to find the value of H2. Okay, so our next target is to find the time from A to B. So here we have to see, let to reach from A to B, time taken t1. Okay, so time taken from A to B, I have taken it is t1. Okay, so this time we have to find out. So all the informations are given. We have to take the equation V equals to u minus gt. Again, it is an upward motion. That's why we have taken minus, right? V equals to u minus gt. V equals to 0, u equals to 19.6 minus g equals to 9.8 into t. Coming to t, so t is t1 here. T1 equals to 19.6 by 9.8, that is 2 seconds. So from A to B, it will take a time of 2 seconds. So how much time it will take to reach B to C? Because if the total time is 5 seconds, so we can write here to reach B to C, time is equals to T2 We are assuming the time is t2 and t2 equals to t minus t1. T is the total time, 5 seconds. T1 is the time to reach A to B, that is 2 seconds. So it is 3 seconds. So the time taken from reaching B to C, it is 3 seconds. That we have find out. Okay, now I am erasing this portion. Otherwise you cannot able to understand. Now our target is to find H2. Okay, our target is to find H2. Now you see, whenever we are talking about initial velocity at A, it is told that 19.6 meter per second. But now we are forgetting this portion. We are not very much aware of this portion. Forget about this thing. We are thinking about from B to C, this motion. So if I write at B, velocity is equals to 0, because you have thrown from A and at the maximum height B the velocity is 0, and in this motion from B to C motion we can write from B to C motion initial velocity u equals to 0, because here we will not take u equals to 19.6 because it is already completed at point B. We are doing it by step, A to B, one motion, we have calculated everything. Now we are talking about B to C. So at B, your u equals to 0. Okay, time t2, that is equals to 3 seconds. We have find out. G, that is 9.8. Okay, and now if u, t2 and g is given to us, we have to find the height h2. So which equation we have to use? So as B to C motion is downward motion, see it is coming downward, so we have to use the equation h equals to ut plus half gt square. So here you have to take plus, as it is a downward motion. If it is upward motion, we have to take it as minus. So let's put the value. Here the value of h is h2. U equals to 0 into 3 plus half of g, that is 9.8, t square. So t square is 3 square, that is 9. Okay, now the value 9.8, so it is 4.9. So 4.9 into 9, 9 9s are 81, 1, 8 is in my hand, 9 4s are 36, so 36 plus 8, 44, 44.1 meter. So I have got h1. Okay, so h1 equals to, I have done in the previous part, that is h1 equals to 19.6 meter, and h2 we have seen it is 44.1 meter. Okay, and then we'll go for the height. Okay, so what will be the height of tower? So here we have to mention height of tower is equals to 44.1 minus 19.6. So it is 5, 1, 4, 2, 24.5 meter. So it is the height of the tower, that is 24.5 meter. Next, till now the numerical is not completed. The velocity of ball on reaching ground. Okay, so we have to find the velocity at point C. So let's do it. It's very easy. Let the velocity at C is equals to Vc. This is your velocity at point C. Now which equation we have to use? So we have to use the simple equation, that is v equals to u plus gt. This is the very easiest one. So we are talking about the motion from B to C. From B to C. So here initial velocity is how much? 0. G, it is 9.8, and T, it is 3 seconds, because to reach from B to C it will take 3 seconds. Multiply 29.4 meter per second. So it is the final velocity whenever the ball reaches to the ground. Though the numerical is very easy, but I have told already it is little lengthy. Okay, see the video. If you not understand in first time, see it twice, thrice. I think this numerical should be very much easier for you. Thank you.